Hi everyone, thank you for tuning in to my session at Festive Tech Calendar. I hope that you are having a great day, great evening, wherever you are watching this video right now. And I hope that you're feeling the season of Christmas coming soon. And I would like to thank you, Festive Tech Calendar team, as well as the Cloud Family team, for having me today and for inviting me to be part of this. And I really like the initiative to unite all the community leaders from around the world to share this their knowledge and contributions for the community, and also for Festive Tech Calendar to support Girls Who Code as a fundraising to help girls in the tech world. So thank you so much. And if you missed the previous session, feel free to check out the other sessions on festivetechcalendar.com. Okay, and today I will be sharing about Azure Durable Functions. Let me just share my screen here. Okay, so I will be sharing about Azure Durable Functions, specifically how to automate notifications, SMS, and calls using it. And before I get started, I would like to share about myself. I'm Jonah Andersson. I'm from Sweden. I work as a software engineer or IT consultant at Forefront Consulting here in Sweden. I code Fullstack.net. I'm a certified Azure developer. I'm also a Microsoft MVP for Azure. And I am also a technical trainer. I am also the founder and one of the community leaders of Azure User Group Sweden. It is a community meetup group that I started this year, and we organize bi-weekly meetings or meetups. So if you're interested to just learn about Azure or cloud or software engineering, or if you're interested to share your knowledge to the community, feel free to join us on Meetup. And I also would like to share that I'm one of the cloud champions of the cloud family this year. So glad to be part of the year ends community event. Okay, so this is the offline version of me as well. I just to those that want to get to know more about me. So I like dog training. I have a 6-month-old Labradoodle. And I also like to play chess in my free time, gardening, and I'm also spending my weekends writing a book, researching about Azure and writing a book about it. And I also try to make a difference by being a mentor. I volunteer to mentor other women in tech, and I also like reading books. And one of the interesting info about me is that since the COVID, when I started working from home, I bought myself a desk bike that I use when I work from home. And before I dig deeper to the topic of the day, I want to go through what I plan to go through with you. So I'm gonna talk a bit about serverless, Azure Functions, what it is, durable functions, the different application patterns, show you some code, live demo, as well as learning resources for you, especially to those that are new in this technology. I decided to have this session in a beginner friendly way, because I want my session to be inclusive for everyone, especially those that are new and a beginner of this Azure Functions as well. So I want to introduce you to cloud, to the different deployment models. So Those that have been working with the cloud computing, you're aware that there are different types of cloud. Of course, we have the private, public cloud, multi-cloud, hybrid cloud, and we also have the different deployment models. So we have as you can see here on the left, that's our traditional on-premise or legacy systems where everything is in one place. And we have to manage it. And as we move to the cloud, from here we have the different deployment models, like the infrastructure as a service, the container as a service, platform as a service, function as a service, software as a service. And today we will be focusing on function as a service, or serverless, in which we manages or build the functions or the logic behind our functions, as well as the data and configurations for it, and the rest, like applications, runtime, containers, operating system, and the infrastructures are taken care of the public cloud providers. And we here in Sweden likes to fika. Fika is the Swedish word for an event where we meet up with our family and friends and colleagues, where we take a break and spend time to drink a cup of coffee, brewed coffee specifically, and have something sweet on the side with a good conversation. So I decided to describe serverless in a serverless Swedish fika comparison way. So monolith is like a layered cake in which you have everything in one place, just like what I showed in the previous picture. The traditional on-premise, you have everything in one place, your servers, your databases, your applications. You have everything in one place. You have to take care of it and maintain it. And cupcakes, they have their own flavors. They're small, they're isolated, they have their own purpose or flavors. They are like also microservices in which each service has its purpose. For example, a service that handles user management, another service that handles orders, or another service that handles product management. So they are like cupcakes. And then there's also containers. So containers are like having sweets and cookies in boxes. So you have everything in one container or one box, and they are easy to carry, and you have everything that you need, different flavors, all that you need for your journey if you're traveling with a box of cookies or containers of cookies. And then there's also serverless. We call it small candies, is called goodies in Swedish. And serverless are like goodies or small candies, in which they are light to carry. You can have it in your pocket. You can bring it with you anytime. It doesn't make you full or too heavy in the stomach, because it's just enough. It's small. It's just like also serverless. The function is functions or serverless functions, because you create it based on you only have to code your logic and the things that you need, the tasks that you need to perform on that, without worrying about the infrastructure that you have on the infrastructures behind. So as serverless is a word that are often misunderstood. So it is not really without servers. There are servers behind it, only that the cloud provider like Azure, Microsoft Azure, is taking care of that for us. We just need to focus on delivering and being productive in our use case. So my point here in this comparison is that the more we go through the left to the monolithic, it also means that you have more control about everything, your infrastructure. But the more we go from left to right, like to microservices, containers, and using serverless, the more the more we gain productivity in the things that we need to deliver to our clients in our applications. So regardless of whatever use case that you have, each of this technologies has actually its purpose. So it just depends on how your organization wants to handle it and what is that strategy. So, but today we will be focusing on serverless, especially because serverless helps us be productive, and we also just pay for what we need. So serverless also solves the problem of concurrency and racing conditions and deadlock in programming. And one of the serverless compute service that Azure offers is Azure Functions, which you can create on demand. You can pay it as you go. It is event driven, which means that if your use case or problem doesn't require, it cannot be solved by this type of service like event driven, then probably Azure Functions is not the right service. But the benefit of Azure Functions, so for example, if you're trying to solve a project that's definitely event driven, so it's an advantage, and it creates developer productivity because as a developer you write less code, and it integrates smoothly with and seamlessly with other Azure services as well as other APIs. So basically, Azure Functions is your code, the logic that you write as a developer in any programming language that you like or supported. And it's also the events plus data. So since it's event driven, an event is required to trigger the Azure function, the function app. And events can be your HTTP trigger, your blob trigger, your IoT trigger, or your storage Cosmos DB trigger, for example. And your data, the data that you passed in as an input, and also the output bindings. And the next one is durable functions. So what are durable functions? So durable functions are extensions, is the extension of Azure Functions. So it is not a separate service. It's a complementary or extension of Azure Functions, which you can use if you need or if you want to write stateful workflows in serverless environments. It is also an Azure compute service. The good thing about durable functions is that it manages, it checkpoints, and it restores the state for you, unlike the normal Azure Functions. So the technology behind durable functions is the Durable Task Framework. So if you want to check it out, feel free to check out that GitHub link. And you can code it with your favorite like primary languages that we have these days, like C#, JavaScript, Python, F#, and PowerShell. And so basically, Azure Functions, what differs them? So Azure Functions is stateless, and Azure Functions is stateful. So if you want to create stateful or workflows that wants to keep its state, then it's ideal to use Azure Durable Functions. So there are different durable function types. There's the client functions that is used in starting the orchestration. Client functions can be your trigger, and it has the entity trigger binding. For example, client functions can be your HTTP trigger or your blob trigger. And once that client function is triggered, it kickstarts the orchestrator or the orchestration. And the orchestrator is a type of functions where you describe how your actions or your tasks are to be executed and in what order you want them to be executed. So Orchestrator is the type of function type where you write your workflows, and it's the orchestrator functions that calls the activity functions. And activity functions are like tasks or the basic unit of work that you want to perform in your durable function workflow or orchestration. And there's also another type called entity functions, commonly used for defining operations for reading and updating durable entities. And it uses a special type of trigger, which is the entity trigger. And it is supported from Durable Functions 2.0 and supports .NET and JavaScript. So the orchestrator, of all the types, the orchestrator is an interesting type, because this is where you write your orchestration or your workflow. So when you design your orchestrator, it needs to be deterministic. Deterministic because your entire orchestration will be replayed, which means that it expects the same results all the time when it is replayed. So this means that you cannot have infinite loops in your orchestrator or anything that's not deterministic. And technology behind it, you can read more about it, about deterministic APIs, through the Microsoft documentation link in here to learn more about it. So deterministic versus non-deterministic, you see a good example here from left to right. We have typical durable functions where we have an orchestrator, and then we also have the orchestrator designs or assigns and executes the workflow depending on in which order you have designed it as a developer. And then we also have the non-deterministic, which means there's no orchestrator. As you can see, they're like isolated. It's one Azure Function app or Azure Functioneer, but they don't have a workflow or an orchestrator. So this means that if there's no orchestrator, there's a possibility that it loses its states when one of the virtual machines where the Azure function is hosted will be restarted. So depending on the type of problem that you're trying to solve, if you want it to be stateful, then it's good to use a determined orchestrator. So there are different constraints when it comes to there are different things that you need to consider when you're writing your workflow in an orchestrator. These are the type of code constraints. For example, it's not recommended from left. They are the ones that are don'ts, and to the right are the do's. So from the left, it's not recommended to write GUID numbers, or random numbers, because it breaks the rules of being deterministic. What you can do instead is use the method new GUID if you need GUID random numbers. So it is also not recommended to write data source or connection strings as well as configuration in your workflow, in your orchestrator. What you can do is you can pass them instead in your activity functions. And then it's also not recommended to use blocking APIs like the common thread methods, round sleep, or delay. What you can do instead is use the context, the durable orchestration context in your orchestrator, which has the great functions to use in your stateful workflows. And infinite loops, not recommended. Where if you really need to repeat the process, you can use the method create as new through the durable context. And the current date time, that the standard one that we have in .NET, it's not recommended, but you can use the current UTC date time that you can access from the durable orchestration context as well. To learn more about the different constraints, this is just a few of those examples. If you want to learn more, there's more in the Microsoft documentation links below. And then I want to discuss about the different patterns and for or application patterns for the durable functions. So the first one is the function chaining, and then we have the fan out, fan in, and then there's the async HTTP APIs, and then the monitor pattern. There's also the human interaction pattern and the aggregator pattern. So first pattern is the function chaining pattern, in which I will be showing an example later on this session. So the function chaining refers to a pattern in which you execute a set of functions in a particular order, like a chain. So like this. So the output of function 1 is required input of function 2, so on and so forth. So the function chaining in action looks like this. For example, I have a HTTP trigger that triggers the orchestration. So here the orchestrator has started, and activity 1 is scheduled. And when activity 1 is scheduled, the orchestrator sleeps. And when activity 1 is done, the orchestrator wakes up. The activity 2 is scheduled. When the orchestrator sleeps again, activity 2 is done. The orchestration is completed. So this is the first workflow or set of the orchestration. So this process will be replayed once when an event happens. Like for example, if the orchestrator gets triggered with a blob trigger or HTTP triggered again. And the good thing when the orchestrator sleeps is that we don't get charged for the activities that are not running. So it's very good when the orchestrator has a sleepyhead. So this is an example of function chaining. And the next pattern is the fan out, fan in pattern, like this. So you fan out and then you fan in. In the fan out and fan in pattern, you execute multiple functions in parallel and then wait for all functions to finish to aggregate the results when it's done. So this is not easy to do on normal functions. It's not easy to fan out without losing its state. You have to save or send multiple messages to a queue before you can fan back in. Fanning back in is more difficult. So fan out and fan in pattern is pretty useful in serverless stateful workflows. And the next pattern is the async HTTP APIs, which is used to solve the problems of coordinating long-running operations with external clients. And it uses you can use HTTP endpoint to trigger the long-running action. And you can also use this in any API endpoints, or if you want to get the status or response of your website, for example. So this is a useful one if you want a stateful async HTTP API that's long running. And then the next one is the monitor pattern. As the word itself, it is used to have a recurring process, a flexible recurring process in a workflow. For example, if you want to monitor batch job processes in a workflow, then you can use the monitor pattern. And then the next one is human interaction pattern. If you want to, if you have a use case in which you need to automate a business process that requires human interaction, So one typical example of this is a approval workflow in which, for example, asks for approval to a person in the company or your organization, maybe the HR, and probably that person is on vacation somewhere in a certain time of the month. And what you can do to automate that business process is that you can have both the external event, which is the response from that person, and also, and along with that, is a durable timer. So if the process is being approved by the person through an external event, maybe by replying to an SMS or an email or clicking on a button on a web app, that event process the approval. Otherwise, you can keep track of the interaction by having a durable timer where you have your durable timeout that checks if that HR manager doesn't reply in 2 days or in 1 week. What you can do is you can escalate the process. So that is the human interaction pattern. The next pattern is the aggregator pattern, which is commonly used for stateful entities. So this is used if you want to aggregate event data over a period of time as a single addressable entity. And this data can come from different resources, and they can come from any time. So you can make use of this pattern, especially for stateful entities. And then those are the 6 patterns, but you can actually create as many patterns as you want, like depending on what you're trying to solve. The workflow is pretty flexible, especially that there are actually support for sub-orchestrations in durable functions. So for example, you can have sub-orchestrators in your orchestrator. So just like this, you can have an orchestrator with 2 sub-orchestrator, and each sub-orchestrator has its own workflow where it executes different types of activity or different tasks. And it supports .NET, JavaScript, and Python. Developing Azure Functions. So when you're developing Azure Functions, you can do it in the Azure portal, Cloud Shell, Azure CLI, with the supported language that you like to code it to. So as for developing locally, you can use Visual Studio or VS Code. And then if you want to work with it locally, you would need to install the latest version of Azure Function Core Tools, as well as if working with HTTP requests or web requests, it's good to have Postman. And also Azure Storage Explorer if you want for local dev. It's also in Azure portal, but locally you can download it to check on the logs or web jobs that's going on behind your orchestration or your instances. And if you're interested to develop Fullstack with front end with Azure Functions, there's Azure Static Web Apps actually support API support with Azure Functions. And if you already have function in production, you can also make use of the feature or the option to bring your own functions. Orchestration details. This is something that this is good to know, that there are orchestration details like the ID, instant ID, the URL of your orchestration instance, the different URLs to terminate, to rage event, and to restart your orchestration. This is the links or details that you can use to take control of your orchestration, or even to handle possible errors. This is in this screenshot. This is taken from Postman while I was doing an HTTP request. And Azure Functions supports CADA. So CADA means Kubernetes-based event-driven autoscaling, and it pairs seamlessly with Azure Functions runtime. And also recently, after the Ignite, Microsoft has released a new product or new service called Azure Container Apps, which is currently in preview. This is I myself is interested to dig deeper as well. So Azure Container Apps is a fully managed serverless container service, and it's built for microservices. And what it does is it scales dynamically based on the HTTP traffic and the long-running background jobs that you have. And it has full support to, for example, CADA and also Dapper. So there's a new documentation released about it. So just check on this link to learn more or to get started with the preview version of Azure Container Apps. So this is how a preview of that. So you can have public endpoints, public background processing, event driven processing, microservices, and its auto scale, how it auto scales and its criteria. All right, coding durable functions when you're developing. It's good to know that you can use Azure Application Insights for monitoring and logging, and Azure Storage Explorer, as I mentioned. When you create a function app or Azure, you develop Azure Functions, you need to associate your Azure storage with it, because that's where all the web jobs or the instances and the logs are saved. And when you're developing or making changes in Azure Functions or Functions app, you need to have conscious versioning between dev, staging, and production. So it's good to know that there's like deployment slots as well that you can make use of, and also side-by-side deployment, especially if you're making a big change in something that's already in production. And as for security, you can make use of the great security tool or security service, Azure Key Vault, to save your connection string and your keys and secrets, as well as configurations. And there's a good link or blog about durable functions blue-green deployment strategies on this link, so feel free to check it out. It was an interesting article to read, and I think you will find it useful as well. And for error handling, usually you get a function failed error exception, so you can handle errors by calling another function activity using a durable timer, logging. Make use of the automatic retry feature by calling automatic retry async, as well as a durable functions monitor that's been recently available on GitHub. So now it's the time for me to show some examples about what I'm gonna talk about or show. So I will be, these are the technologies that I've used in this project, automating SMS and calls using durable functions. So I use a function training pattern. I have my code in C#.NET in core. Azure Functions course tools. I use Visual Studio or VS Code. I have Azure Storage Explorers, and I'm integrating my app with Azure Service Bus to save a queue message, Twilio API, Sendgrid API, Postman, and GitHub Actions or GitHub to deploy that project as well. So here's my demo, how it looks, the workflow. So what I have here is I have an Azure blob trigger that gets triggered when I upload an image to my Azure storage. that is hosted in Azure. And when the Azure blob is triggered, it kickstarts my orchestration, which has the function chaining workflow or pattern. And then I passed in my blob image data. And then what I do is I'm going to create a queue message and send that message to my Azure Service Bus. And then when it's done, I'm going to send an SMS and call via Twilio. And then send a notification email using Sendgrid. So that's like the function chaining. I have 3 activities after to chain after I upload an image to my blob or storage, Azure Storage. So this repo is available as a template with instructions and README guide on this link, GitHub, Jonah Andersson Serverless Lab Azure Durable Functions template. And the expected results on my workflow would be this. I receive an SMS, I will be getting a call, and I will be receiving also an email. So let me just do my live demo. Let's see, and switch to this one. Let's see, I have my storage here, and I also have my code. So let me just show you my code. Let's see. So here I have a very simple app. This is a simple app where, let's see, I think that was the wrong project. Let me just open the correct one. Let's see. Okay, it's taking time. Okay, let me just prepare. All right, this is the right one. Let me just switch to this. All right, so in here I have a function app on Visual Studio, a simple one called Durable Storage Functions, in which I have actually organized my functions into folders. So I have my solution for the models, and I have my client function, which has the blob trigger, and then I have my orchestrator, which is called Azure Storage Orchestrator, and I have my activity functions, which are the tasks that I'm gonna be doing. Let me just see. Yes. So let's see. Let me just zoom it out. Okay, that one maybe, so you can see me. Okay, so what I have here, so I have those folders. So what I have here is my blob trigger, and in my blob trigger I have, this is where I kickstart my orchestration. This is my client function, in which on line 18 I have the name of my container. I have the connection string that I have in my local settings since I'm working locally. And then I have my logger, and also I use this when you the client function uses the durable client, and it uses the interface iDurable client orchestration client. And in my in this client function I have a try catch blocks that I just start by logging, And what I do is I check if my blob is not null, and if it's not null or empty, in line 29 I create an object for it with its properties like the name, blob URL. And then what I do is I want to save the instance ID in case I want to process or check on that exact instance later. And I use the durable orchestration client, which is named starter, in line 39 to start a new or to trigger the orchestration using the keyword or the method start new async. And in my start new async method in line 39, I passed in the name of my orchestrator, which is Azure Storage Orchestrator, and then I passed in my blob item, and then I have an if else condition or try catch if to handle the errors. And then in my orchestrator I have my durable orchestration context, and it has the orchestration triggered that was triggered by the client function. And what I do is I get the value from that pass parameter on line 22 by using by calling the method get input from the context, and then I passed in my object cloud blob item, which is a class where I have set up the different properties that I need for this. And here you can see my first chain, and that is to send the blob details to service bus queue, which means in that method I will be creating a queue message and save it to my Azure Service Bus. And then when that Service Bus message or queue message it's not null, it's done, I'm gonna send an SMS and call to the user by calling another activity, send call activity to Twilio, and passed in my Service Bus message. And then when it's done, I'm gonna send an SMS and call to the user, and after that I'm gonna send an email notification using Twilio. So this is just a very simple example on how we can integrate Azure services like Azure Service Bus and Azure Storage in a durable durable workflow using durable functions, and also how you can integrate it with external APIs like Sendgrid, Twilio, and other providers. So in my send message to service bus queue, I also have a set of logic in here in which I have passed in my uploaded blob. In line 19 I do my logging, and then as I mentioned I have my own Azure Service Bus configuration that reads the data from my local settings. And then I have my service bus connection, that's the connection string that I have on my service bus namespace in Azure, and then the name of my service bus queue. And I have a try catch and if condition to compose a message, queue message, and I use the service bus client in line 43 to create a connection, and then 46 I create a sender, and then on 49 I create a service bus message, and then I send that message to my service bus queue and just log it, and then I return that queue message to process as an input for the next function. And here is my activity or activity functions for sending an SMS call to Twilio. Here I passed in the service bus queue message. I have my own configuration file here from line 22 to 23, and I have my settings here, my values to do it locally. And I use the Twilio client in I had to add it on my in this project to be able to use it. So as you can see in my project, I have Twilio on packages, I have Sendgrid, and also have the Service Bus packages in here. And what I do is I create an SMS message, and I have a from and to number set based on my settings. And then I also create a call by using the Twilio API call resource, and use TweML to create it, and then my from to number. And I can log the information by calling the variable call for the ID, the status, or if it was completed or not. And as for Sendgrid, I send an email. Sendgrid, I have my own configuration here in line 25 to 29. My Sendgrid API keys and secrets and the email address. And I also have a client, Sendgrid client, that I need to send an email, and I myself can check if I want to check the status, if it was successfully sent or not. And there are Sendgrid, Twilio have great documentations for development, so it is worth checking out. So let me just run this function while I'm also, let's see, it's hard to have one screen and then you have to have a lot of things to do. So here is my, let's see, let's make it smaller. So here is my function. It's active. It's waiting for my activity. So it's waiting right now. So here you have my trigger, my activities, and my orchestrator. And what I want is, I have installed the Azure Storage Explorer locally. I like using it locally when I'm working locally with this. And what I'm gonna do is I'm gonna prepare this to upload images to my Azure storage. And let me just get my phone just to do a live demo. Let's see. So I have my blob containers. The name of my blob container is photos container, and have my function up here running on Visual Studio locally. And let's see. So I'm gonna upload the image with the Eiffel Tower. So I'm gonna upload this, and when this is uploaded, it's queued right now. This should trigger the orchestration that I'm running locally. It's still transferring. I also have my iPhone here, and let's see. It says that it was uploaded, but it's not triggered. Let's see what's wrong. Clear completed. Let me just stop this again, double check if it's the right name. Photos container. Okay, let's see, let me just rebuild. And start again. So I have this one again. Oh, I hope this works. It's hard with live demo sometimes, especially local demos. Let's see. I have that one, and then I have this photos, and then I'm gonna have my storage in here. It was right, it was correct. So I'm gonna try another photo here. Let's see, maybe the bridge. Let's see, let's try. So I hope it works. Otherwise, maybe it's my computer that's slow. So here it works after rebuilding. So here, here I have my orchestration that got started, and you heard it. I got a call, and I also got an SMS here. It was in mute. I got an SMS here. I got an SMS, and I also got a missed call, and it went too quick. It was so like seconds. It went quick. But I want to go through what happened here. So I can go through the stumps here. Let's see. So okay. So here I had my log. So it was like it went pretty quick from 20 from that time to 2053 to 2054. So in less than a minute, a lot of things happened, calling me, sending me an email and stuff. But here was the log. So I started my orchestration triggered by this blob name, and then that's the name of the image that I uploaded, and then I started my orchestration with this ID, and then I have started and executed my orchestration, and then I received I sent a message to Service Bus. We can check the Service Bus as well. And then I also received a message, and I also received a missed call. It says call completed because I missed answering it on time. And so that was the orchestration. And if we are gonna go to my Azure account, let's see. If you're gonna see, let me just, okay, if we're gonna go to my Azure account, I have my storage here, I have my queue, a service bus namespace, and I have queues, and this is the service bus queue that I am integrating with my durable functions. And let's see, let's open the Service Bus Explorer. And what we can do, we can refresh first. And it shows that I have a message, 2 messages. Probably one of them was the previous test that I did. And if we're gonna pick the 2 messages, one of them should be the one that I have created today when this video is recorded. Let's see. So that was it. It's here, and I want to show you as well that I did actually received an email, which is this one. Let's see. Here was the message that I also received to my work email sent from my web personal address. So a new cloud blob message uploaded, and it was this image that I uploaded, the bridge that I uploaded from my local file, which is this one. So that is my demo. Let me just go back to my presentation again. So that's my code demo. I received an SMS. I got a call, which you didn't hear actually because it went too quick and my phone was on silent. And I also received an email, and I also got it on my phone, on my clock. So it's time to it's ending my session soon, but the key takeaways of this serverless session and durable functions is that with serverless and durable functions, we can focus on productivity as developers. We can solve complex serverless use case scenarios, build stateful workflows. We can automate our processes using durable functions, especially the example of the fan in, pan out pattern, or the function chaining, as well as the human interaction pattern. And of course, with serverless, you only pay for what you use, as we saw the orchestrator. When the orchestrator sleeps, it's good because you don't actually get paid for the functions or the activity functions that are not running. So that's a good thing of having a deterministic orchestrator. So I want to conclude my session that as a developer, I love serverless because I can solve complex problems, build modern apps, and it makes me productive. And that's it. I want to thank you so much for spending time with me listening to my session. I hope that you have learned something new about durable functions. And if you have questions, feedback, feel free to connect. I have my QR code from my LinkedIn here. And feel free to visit my website and contact me that way as well. Otherwise, you can follow me on or direct message me on Twitter. I have CJ Kodere as my handle. And thank you, and would like to greet everyone happy and Merry Christmas, and thank you for having me today. Bye-bye.